Okay, here I am. I'm going to try to power my way through the answer key for this practice test. This is asking which of these are functions, and if they are not, just say why they are not. As you look at this, this is the input here, each of the first coordinates, and that's the output. So what you want to make sure is that you never repeat an input without having the same output. And here all of the inputs are different, so it really doesn't matter. If we were to plot this, we get just a series of points, so that's okay. It passes the vertical line test. That's really what we're asking. Here, however, I've got the same input. I've got a repeated input. Every time I'm putting in one, I'm getting a different output. So if I plotted this, I would just have points like this, and that definitely fails the vertical line test. So why? They just fails vertical line test. There we go. FVLT. You could use that if you want. The next one is just a simple graph, a distance and a time. Again, vertical line test. Even though this is approaching vertical, it is not yet vertical clearly, so it is okay. So that is a yes. Here you want to just be careful. This is a step value function or a piecewise function. You want to make sure that these endpoints are not ever both filled in, and it would fail. But we're okay. So again, this is yes. So 3 out of the 4 of those are yes. All right, so number 2 here, it's sketch the graph of the piecewise defined function. You just want to sketch each of these graphs over the given domain here, and just be careful about it. Looks like we're missing a horizontal axis here. This is a slope of 1/4 and an intercept of -2. So if I go down 1, 2, and then do a rise of 1 and a run of 4, or a rise of 2 and a run of 8, that's going to give me that approximate equation, all right, or that approximate graph. So y equals 1/4 x minus 2. But it's only if x is less than or equal to -5. So if that's -5 and I come down here and it's allowed to be equal to, so I would shade that in and sketch it like that. Then it's 10 between -5 and +3. So I go up 5 and 10 and it jumps all the way up here, and that's an open circle because that is not equal to. It's across 10, and at 3 then I'm going to have this be an open circle here as well. So there it is between those. That's y equals 10, or f of x equals 10, I should write. And then finally, it's a parabolic opening downwards, and I might as well start this when it's equal to 3. If I plug in 3 there and square it, I get 9. That's a -9 plus 10. That's a +1. So it's going to be right here at a +1, and it's equal to, and then it's opening downwards. So if I just plug in another point, maybe like 5, 5 squared is 25, -25 plus 10 is -15. So here it'd be down 5, 10, 15, something like that. So it's opening quite steeply downwards in that direction. All right? And if you want, you can label these points like 3, 1, here's 3, 10, here's -5, 10. But if you've drawn a good enough graph, it should be pretty good. This would be a good one to label, and that would be what, -5. And if I plug in -5, oops, we got a fraction, so a little bit awkward, but -5/4, that's -1 1/4 minus 2 more is -3 1/4. All right, that's the first page done. Then the second page, put the following into standard polynomial form. Identify the degree and lead coefficient of the polynomial. But don't solve this. There's no equal sign. There's nothing to solve. Every once in a while people try to factor it or something and solve it. I first want to FOIL this carefully. This is 3 times then x squared minus 2x plus 1. Don't just distribute in and make it x squared minus 1. That would not be correct. And then nothing to FOIL there, but I just distribute that into each of those, and I get plus 4x to the 4th minus 8x squared plus 4x. And then when I bring in the 3 to each of these, I will get 3x squared minus 6x plus 3, and then plus this whole lot, which I think I'm going to save myself writing just in the interest of time. And I go with the highest degree. When I combine these, I'm going to have 4x to the fourth is my highest degree. Then there's an negative 8x squared and a positive 3x squared, so I'll get then, minus 5x squared. And then for the x terms, that's right there, positive 4 and negative 6 will give me negative 2x, and then finally plus 3. So that is my polynomial when it's all cleaned up. The lead coefficient, that is what's called the lead coefficient, and that is the degree. A bit confusing to have them both before. On a test I would try to be a little bit better about that. That's not very good, but they both happen to be 4. Alright, so that one is done. Next is graph the following. Okay, again we've got two different functions. This is really sort of two problems, but I'm giving you extra practice. On the test that you're going to take, probably be just one. In this case, in both cases, you really want to think about factoring. I can take an x out of each of these, and then when I do that, I've got x squared and x and 30. And if you're good at factoring, you'll see that that's got to be x, and then minus 6 and plus 5. Again, when I take out an x from everywhere, it becomes x squared minus x minus 30. Negative 6 and positive 5 multiply to make negative 30. When I do the rainbow check, I get the negative x, and then x times x gives me x squared. When I multiply it all by x, I'll get that. This up above then, if you think about it, I can cancel an x here with one of these x's. So this is the same as saying 2x squared over then x minus 6 times x plus 5. So this is going to have one of those removable discontinuities when x is